Hello and welcome. Hopefully this is just going to be a real quick demonstration of the new Part 9 bracing calculator that I've developed. The idea here is that a user can use the calculator and follow along with this video. So it's going to be hopefully pretty brief and touch on some of the basics of the calculator. To understand the calculator though, we need to understand a building. So here we are in SketchUp, the very simple Part 9 structure. Let's just consider it's a house with a bit of a 3D form, just for the purpose of illustration. So we take that building and we turn it into a floor plan. We start to get something like this. Once we have a floor plan, we need to understand our brace wall plan and how it's laid over that conceptually. So we move along here. We've got the brace wall bands along the horizontal axes noted in green there. Here we have the brace wall bands noted in red along the vertical axes. If we turn them into the 3D, we start to get something like this. And then further along, if we overlay the rest of the building, we start to see how those brace wall bands intersect with the form of the building. While we're here, we'll just note the height of the roof. So here we are. We have 6'6" for the roof height. And now jumping now into PowerPoint, we can get a greater understanding of our building and our brace wall band plan by identifying some measurements here. So again, we're looking at floor plan of the brace wall band plan to understand building plan dimensions and our brace wall bands. So here are our building plan dimensions. I've said this a number of times in previous videos, but my understanding of building plan dimensions for lateral bracing as far as Part 9 is concerned is to understand how our building can fit into an extending rectangle. So to do that here, we have 38 feet along the vertical axes and 40 feet along the horizontal axes. These measurements are pulling out the greatest extents of the building. To understand our band spacing, we need to understand the furthest distance between the bands in each orthogonal direction, the furthest distance between the end bands in each orthogonal direction. So here along the vertical axes, we have 36 feet between our furthest bands, and along the horizontal axes, we have 38 feet along the horizontal along the horizontal axes. Once we know that dimension and how many bands we have, we can start to identify our bands. So here we know we have 3 bands along the vertical axes and 3 bands along the horizontal axes. Once we have this information, we can jump over into the calculator and start inputting some of it. So here we are in the calculator. Some of you may have seen this before in the past. Some of you may be new. The idea here is just to have a really quick and easy demonstration video to go through some of the functionality and how to use it. The idea being that there'll be a little bit of a video to guide you through some of the tabs. Anyway, so this is going to be the main launch page with a disclaimer, obviously, and a welcome. This video that I'm posting will be right here. And a little bit more information around the current version of the calculator and anticipating there will be updates. Obviously, as the code updates, the calculator will have to update as well. So a little bit of functionality here. So the first thing we're going to do is launch the calculator. Run the script. This unlocks the calculator if you're starting for the first time and exposes all the pages that are going to be available to the user. So here we are at the first tab, we're considering the I-line general inputs. From here, we have a few entries in here, so I'm going to reset the calculator. The script is running to reset all the values. So when we're using the calculator, any cell that we see that is a mauve color requires an entry. Any cell that is blue is going to be a calculation that comes back. There we go, the script is finished. So some administrative information. Let's just start with this is just administrative, has no effect on the calculator. So that's just some information that's going to be pulled back into other forms in the calculator so that just for administrative purposes. Now we're getting into site location. I'm going to say we're in Nanaimo. And say our site class is C. Exposure is rough. See, information is coming back. Whether construction is normal. For our demo, we had a slab on grade, so there is no wood frame floors. You see the calculator is interacting with my inputs. Here we get to our first filter. So these toggle filters just remove or hide the cells that are not required for your calculation. So you can click it. It truncates the calculator, so now I just have a few more inputs to put here. So we had our vertical dimension, building dimension along our vertical axes. For our example, that was 38 feet. The building dimension along the horizontal axis was 40 feet. We had our eave to ridge roof height, which I measured in SketchUp, and that was 6'6". The weight of construction on this story for bracing, we're considering it to be normal. Now we get into a really brief report. I've gone through this in detail in other videos. So once we have all that, that's all the Mauve cells that have been finished. I can go back up and check it. So we have a few different options to navigate here. So the next page that I'm going to navigate to is I2 bands here for further inputs. So these are all the bands that are, these are all the input sheets, all the user input sheets that are required. So here we are on I1. We're going to move along to I2. And here we are, you can see I1 is now complete, and we're in I2. So again, you can see we've got a fair bit of information here. Some of it is unnecessary, so we're going to toggle filter for the cells that are required. And there we go. So it just truncates the calculator to make it a little bit easier to handle. Now we're looking at the number of bands along the vertical axes. So in our example, that was 3. The total distance between the center lines of those bands along the vertical axes, if we recall, that was 36 feet. And now the calculator is determining our average spacing for our bands on that story in that orthogonal direction. If you happen to click on a cell that you shouldn't be, and you want to try and delete something or change something, you're going to get a prompt here. The idea is that basically, anyone can access the information if they want it, but we don't want people entering information in where they shouldn't, where it's going to affect their calculations. So again, all the cells here that were mauve are now green, so we can move on to the next tab. So here we are in the design and feedback tab, I3. So again, we're going to toggle filter for required. And again, it truncates the calculator. So now a little bit more information. This is going to be, I think, most important to designers and builders. So here we are defining basically what reference framing type we are going to be using and some of the other construction requirements that we'd like to put into our design. So along the top here, we have 4 different pitches that are sort of a quick way to tell the calculator how to design your bracing calculations. The images are representative of the types of construction. So here on the left-hand side, we have WSPA intermittent. And so if you could compare that to WSPD intermittent, the difference between these two calculations is that WSPD, that reference framing type, is required to be designed into the roof system. All right, so that's where you can see these little red triangles here, and there's little red lines above the brace wall panels. The difference between WSPA intermittent and WSPA continuous is that this sheathing is continuous between the brace wall bands. And so basically, I'd sort of considered these to be, these 4 types to be sort of curated for contractors. In my opinion, these are probably going to be the most efficient ways to construct Part 9 buildings with Part 9 lateral bracing. And I won't go into detail now, but that's why I decided on these types. So basically, these sort of peach colors here are buttons, so you can apply that. So let's say WSPA continuous, so just click that. And so now we're informing the calculator to make those decisions in our brace wall band plan. If I was to change it to another one, it's happening there, and then WSPD continuous, for example. And so we're putting information into the calculator based on these sort of styles. I'm going to go through and identify all the brace wall bands that we have in our plan. The calculator permits up to 10 brace wall bands in either orthogonal direction. And so once we have this, you can see all the green cells here are cells that we've actually put an input into as the user. We can come in here after that's happened. So say, we wanted to change one of these um, brace wall bands to, for example, remove the interior drywall. We can do that, and the calculations are taking place here for us automatically. There are also a bunch of other reference framing types that are available to the user. And I don't go into it in depth, but the calculator can function that way as well. So if you're a more advanced user and you want to get into the depths of pipeline lateral bracing, there's lots of different opportunities here for you to make different selections for the reference framing types. There it is. Okay. So that was the last input um, in terms of the input pages. So, no, it's not here. It's I4. So this isn't affecting the calculations, but this is just a simple report to make it a little bit easier to understand if you're compliant and in which way that you may be compliant. So here we have the tables method and the alternative method for calculations, and then the users provided. So let's say we put in 9 feet here, 8 feet here. All right, so you can make adjustments, fine adjustments down to the 16th of an inch. And here you can see if you're passing or failing as far as the alternatives or the tables method is concerned. The last input that we need to make is on R4. So I'm going to toggle to that now. And this relates to construction requirements. Here we have builder preferences. I've gone through this in detail in my previous videos. You can come through and make the selections that you think are appropriate to your design. One of the things I like about this calculator is that you can tell the calculator that you want to essentially just use one style of nail on all of your fastening of your sheathing. To me, that's going to be of great advantage to contractors. So that's all our inputs made. We can head back to the print dashboard. Come through here. So this is a print dashboard to help us collate the PDFs for printing. So there are lots of different reports that have now been sort of generated based on the user inputs. If we want, we can select the whole package, all the checkpoints in. So I haven't touched on it, but there is a way to add a custom climate and produce an SMAX report through the calculator. I'm not going to need them because I used a climate that was assigned through the BCBC notes. So I can unclick that. I'm going to take out the length compliance report as well, just for the time being. So once I'm comfortable with all of the reports that I want to generate, I can print a PDF package, test it. This is the test. So now the calculator, through the scripts, is developing a PDF package for us. My computer is a little bit slow, but you can get the idea eventually here. So there's our PDF package compiled and ready to download. And here it is. So it calls it Putnam Bracing Calculator test. That's what we generated before, and the date. Obviously, you could put in whatever information you want to call it, or you could rename the file in the future. So this is just a collation of all of the reports and inputs pages that we have called out on our print dashboard based on our inputs. So that was just our first I1 page. Set of bands. That was the I3, the design and feedback tab, where we're generating a quick overview of the lengths. And now we get into some of the reports. I didn't touch on these as we were going through the calculator, but these are all generated based on our inputs. You can go and review them through the calculator, through the tabs, if you want to check them out. But basically, these are sort of simple ways to present the building code information for compliance. So they'd be great for your building permit submission. This is the unadjusted lengths tables. This is the calculation method tables, key factors. The alternative method factors and coefficients. This is the construction report, part 1, and the construction report, part 2. So this gets into the details of your different types of sheathing materials required, the nailing patterns, for example. This is a comparison report that looks at essentially the building code requirement to compare the calculations for wind and the calculations for seismic, and then select the most restrictive. This is the calculation for the top plate nailing requirements in the building code. There's quite a bit of calculations that take place just to determine the amount of nailings for a top plate in a brace wall band. But all the calculations are here, essentially all the workings that feed through into the reports. This is a matrix that outlines all of the key factors that are used in the calculator. We only had one story for bracing, which was for our wall supporting our roof, which is why everything else is grayed out here. But if you have a more complex structure, then you're going to get more to this matrix. And this is a compliance pathway matrix, just showing what code pathways are actually available to this design that we put in. This is a truncated version of the BCBC, looking at the hourly wind pressure unadjusted lengths tables, truncating it down to what is pertinent to our design. And the same thing for the seismic values for the S-max values. So again, it's a truncated version based on our S-max bracket. So there we have it. It's just a quick and easy overview. I'd love to hear your thoughts on it all. Feel free to reach out. Thank you.